Hi everyone. In this class we are going to see in unit number 1 graphical method. Already we have seen what is linear programming problem and formation of linear programming problem. Here we have to use a graph to solve a linear programming problem. The problem method is graphical method can be applied for linear programming problem involving only two variables. Linear programming problem involves two or more variables. In case two variables alone it will be involved means we can apply the graphical method. One variable in the x-axis, the another variable in the y-axis. Step 1. Take inequality constraints as equalities. To draw the line, we have to find 2 points. By putting x1 is equal to 0, we get 1 point. By putting x2 is equal to 0, we get another point. So, in a linear programming problem, the constraints are inequalities. So you have to write in an equation form first, then you have to substitute the value of x1 is equal to 0 means we get the value of x2, and x2 is equal to 0 means we get the value of x1. In step 2, plot the points and draw the lines accordingly. So for every equation you have 2 points, so you have to plot these 2 points in a graph and draw the line. Identify the feasible region. The unknown corners can be determined either from the graph or by solving the constraint equation corresponding to each corner. So we have to find out the feasible region because the total constraints, we have 3 or 4 constraints means we have to find the common portion for the constraints. The unknown corners can be determined by the graph, otherwise we have to solve the equation to get the values. The intersecting points on the boundary of the feasible region are called as corner point. Substituting these points in the objective function, we get the values of the objective function. So the intersection point you have to find by solving the equation, otherwise by using the graph. In final, you have to substitute these values in the objective function. If the problem is minimization, then the minimum of the above values is the optimal value. If the problem is maximization, the maximum of the above values is the optimal value. So for this we have to come with the problem. For the first problem is solve the following LPP by using graphical method. So here the two variables are involved by x1 and x2. So the problem is the objective function is maximization of z is equal to 5x1 plus 3x2. Subject to the constraints are 3x1 plus 5x2 is less than or equal to 15. 5x1 plus 2x2 is less than or equal to 10. Always x1 and x2 will be greater than or equal to 0 because this is non-negative. So first you have to write the first constraint in the equality form because it will be in the less than or equal to. So this is an equal form means 3x1 plus 5x2 is equal to 15. First you have to put x1 value will be 0 means we get the value of x2 is equal to 3. So 0 comma 3 is 1 point. Similarly you have to substitute x2 is equal to 0. So 3x1 is equal to 15. So we get the value of x1 is equal to 5. So the another point is 5 comma 0. So in a graph you have to plot 0 comma 3 and 5 comma 0. Join these 2 points, that is your first constraint line. The next point is 5x1 plus 2x2 is equal to 10. So for this x1 is equal to 0 and 2x2 is equal to 10. So x2 value will be 5. So one of the point is 0 comma 5. The next you have to substitute x2 is equal to 0. So 5x1 is equal to 10. So x2 value will be 2. So 2 comma 0 is the another point. So in a graph 0 comma 5 and 2 comma 0 you have to plot the points and draw the line. So in a graph we get like this. The first constraint is 5x1 plus 2x2 is less than or equal to 10. The next constraint is 3x1 plus 5x2 is less than or equal to 10. So both the values are less than or equal to 10 means in the line left side we have the region. So both the lines we have a region means for the common portion is you have to plot it by the points A, B, C. That is your common region because these two constraints are intersecting at a point B. So up to 0, 0 comma 0 is one corner, another corner is 2 comma 0, the another corner is 0 comma 3. You have to find out the B point using the graph, otherwise solving the constraint equation. So you have to solve the constraint equation and find out the point. You have to check whether the point will be correct or not using by the graph. Now we have to find out the value of B by solving these two equations. So first equation you have to multiply it with 5. Second equation you have to multiply it with 3. So you have to change the sign and simplify means we get the value of x2. Substitute the x2 value in equation number 1 or 2. Anything you have to substitute, we get the value of x1. So we get the point of x1 comma x2. So we have to consider this is A point, B point, C point. Now we have to come with the objective function. So our objective function is maximization of z is equal to 5x1 plus 3x2. So each point you have to find out the value. So at a point A of 0, 3 is equal to 9. At a point B, we have the maximization of z is equal to 12.36. At a point C, 2, 0 is maximization of z is equal to 10. From these 3 points, the objective function is maximization, so we have to consider with the maximum value. So the optimal solution is maximization of z is equal to 12.36. So this is your final answer. Similarly, we have to come with the next example. The next example contains 3 constraints and the problem is minimization of z. So minimization of z means in the final solution will be the different. We get the optimal solution by taking the minimum value. So here 3 constraints are given. So find out 3 plotted points, that is 3 lines. So 6 points you have to find out and draw the 3 lines. For both 3 constraints, the common region is your feasible region. So first you have to change the first constraint to equal form. X1 plus 2, x2 is equal to 2. Put x1 is equal to 0 means 2, x2 is equal to 2. So x2 value will be 1. So 0, 1. The next constraint will be, the next point you have to find out by substituting x2 is equal to 0. So 2, 0 is the another point. Similarly, using second and third constraint, we have to find out the points of 0, 3 and 1, 0. 0, 2 and 1.5, 0. Using these 6 points, you have to find out the feasible region. So in that point, you have to find out, that is the intersection point, you have to find out these 2 constraints. So that is very important. So for the here, we have to find out the constraints of these 2 intersecting point will be calculated by the line equation. The line equations are the constraint equation. So the constraint equations are 3x1 plus 6x2 is equal to 6 and 3x1 plus x2 is equal to 3. So using these 2 equations we have to solve means we get the value of 0.8 and 0.6. So now we have to substitute in the objective function. For the first point A of 0, 1 means we get the value 2. B means we get 4.4. C means we get 2. So the objective function is minimization. So we have to come with the minimal value. The optimal solution is minimization of z is equal to 2. That is your final answer. So go through these 2 problems. In the next class, we have to see the next